take the examples on integration by parts and its corollary. Integral of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Now we are going to take example. Evaluate integral of e to the power x into cos x minus sin x divide by sin square x dx. Now we want to evaluate this example by using this corollary solution. Let I is equal to integral of e to the power x into cos x minus sin x divide by sin square x dx. Now separate the divide. Integral of e raised to x into cos x divide by sin square x minus 1 upon sin x dx. Now 1 upon sin x can be written as cosec x. Integral of e raised to x into cosec x into cot x minus cosec x dx. Now this can be written as I is equal to integral of e raised to x into minus cosec x plus d by dx of minus cosec x dx. Here f of x is minus cosec x. D by dx of minus cosec x is cosec x into cot x. So we get minus e to the power x into cosec x plus c. So this is the integration of this function. Separate divide. So sin square x can be written as sin x into sin x. 1 upon sin x can be written as cosec x, and cos x upon sin x can be written as cot x. So this is the solution of this example. Now we are going to take the second example, next example. E raised to x into 1 minus sin x upon 1 minus cos x dx. Now we want to find the integration of this function. We want to evaluate this function. So how we can evaluate this function? Let I is equal to given function e raised to x into 1 minus sin x divide by 1 minus the cos x dx. Now formula for 1 minus cos theta is 2 sin square theta by 2, and half angle formula for sin theta 2 sin theta by 2 into cos theta by 2. We get integral of e raised to x into 1 minus 2 sin x by 2 into cos x by 2 divide by 2 sin square x by 2 dx. We apply the formula for 1 minus cos theta and sin theta. Now separate divide. Integral of e raised to x into 1 by 2 sin square x by 2 minus 2 sin x by 2 into cos x by 2 divide by 2 sin square x by 2 dx. Now we write this function in this form: e raised to x into 1 by 2 into cosec square x by 2 minus 2 cancel, 1 sign cancel, we get cot x by 2 dx. Now derivative of cot x is minus cosec square x by 2. So we get I is equal to integral of e raised to x into minus cot x by 2 plus d by dx of minus cot x by 2 dx. Here first function f of x and derivative of f of x means minus cot x by 2 plus a derivative of minus cot x by 2. So we get e raised to x into minus cot x by 2 plus c. So we get minus e raised to x into cot x by 2 plus c. So this is the required answer. We here apply half angle formula and we get the solution. Next example. E to the power x into log x plus 1 upon x dx. Now solution of this example: let I is equal to integral of e to the power x into log x plus 1 divide by x dx. Now separate the divide. We get integral of e to the power x into log x plus 1 by x dx. So derivative of log x is 1 by x, but derivative of 1 by x is minus 1 by x square. Means here derivative of log x is 1 by x. We get e to the power x into log x plus d by dx of log x dx. We get e to the power x into log x plus c. This is the required solution of this example. Now we are going to take the next type of example. Integral of e to the power x into root 1 minus x square into sine inverse of x plus 1 divide by root 1 minus x square dx. Now we want to evaluate this function. Let I is equal to integral of e raised to x into root 1 minus x square sine inverse of x plus 1 divide by root 1 minus x square dx. Now separate the divide. We get integral of e raised to x into sine inverse of x plus 1 upon root 1 minus x square dx. Now what is the derivative of sine inverse of x? So the derivative of sine inverse of x is 1 upon root 1 minus x square. Integral of e raised to x into sine inverse of x plus d by dx of sine inverse of x dx, and integration of this function is e raised to x into sine inverse of x plus c. So this is the integration of this function. Now we are going to take the next example. Integral of e to the power x upon x into x into log x bracket square plus 2 log x dx. So we want to find the integration of this function. For the solution, we consider this function is equal to I. Now this can be written as integral of e to the power x. Multiply by 1 by x to this bracket, we get log x bracket square plus 2 log x upon x into dx. Now d by dx of log x bracket square, derivative of this function is 2 log x into derivative of log x. Derivative of f of x to the power n is n into f of x to the power n minus 1 into f dash of x. We get 2 log x into derivative of log x is 1 by x. So we write this function. Therefore, I can be written as integral of e to the power x into log x bracket square plus d by dx of log x bracket square dx, and integration of this function is e raised to x into log x bracket square plus c, where c is the constant of integration. Now we are going to take the next type of example. Next example, e to the power x into x plus 3 divide by x plus 4 bracket square dx. Now we want to find the integration of this function. Let I is equal to integral of e to the power x into x plus 3 divide by x plus 4 bracket square dx. Now denominator contain x plus 4 and numerator contain x plus 3. Then add 1 and subtract 1. We get e raised to x into x plus 4 minus 1 divide by x plus 4 bracket square dx. Now separate the divide, we get integral of e to the power x into 1 upon x plus 4 minus 1 upon x plus 4 bracket square dx. Now we know that derivative of 1 by x is, now we want to find d by dx of 1 upon x plus 4, and derivative of this function d by dx of x plus 4 raised to minus 1, and derivative of x to the power n is n into x to the power n minus 1. We get minus 1 into x plus 4 raised to minus 2 into 1 plus 0. So we get minus 1 upon x plus 4 bracket square. So this function can be written as, I can be written as integral of e to the power x into 1 upon x plus 4 plus d by dx of 1 upon x plus 4 dx. So by using theorem e to the integral of e to the power x into f of x plus f dash of x into dx is e to the power x into f of x plus c. So this can be also written as e to the power x upon x plus 4 plus c. So this is the solution of this example. There is an algebraic function, then we have to solve this example by using this method. Now we are going to take the next example. Integral of e to the power x into x minus 1 upon x minus 1 x plus 1 bracket cube dx. Now we want to find the integration of this function. So what is the function in the denominator? X plus 1 and minus 1. Integral of e to the power x into x plus 1 minus 2 divided by x plus 1 bracket cube into dx. Now separate the divide. We get integral of e to the power x into 1 upon x plus 1 bracket square minus 2 upon x plus 1 bracket cube into dx. Now derivative of first function d by dx of 1 upon x plus 1 bracket square is equal to d by dx of x plus 1 raised to minus 2, and derivative of this function is minus 2 into x plus 1 raised to minus 3 into derivative of x plus 1 is, derivative of x is 1 and derivative of 1 is 0. So we get minus 2 upon x plus 1 bracket cube. Therefore, so this function can be written as integral of e to the power x into 1 upon x plus 1 bracket square minus d by dx of 1 upon x plus 1 bracket square into dx. d by dx of 1 upon x plus 1 bracket square is minus 2 upon x plus 1 bracket cube. So we get e raised to x upon x plus 1 bracket square plus c. So this is the solution of this example. Now we are going to take the next type of example. Integral of e to the power x into 1 plus x square upon 1 plus x bracket square dx. Now we want to find the integration of this function. Let I is equal to given function. Now this can be written as e raised to x into, we add 1 and subtract 1 in numerator, x square minus 1 plus 2 divided by 1 plus x bracket square into dx. Now this can be written as integral of e raised to x into x square minus 1 divided by 1 plus x bracket square plus 2 upon 1 plus x bracket square dx. Now x square minus 1 can be written as by using the formula a square minus b square. Factor of a square minus b square is a plus b into a minus b. Applying this formula here, so we get integral of e to the power x into x minus 1 upon 1 plus x plus 2 upon 1 plus x bracket square into dx. Factors of x square minus 1, 1 means 1 square, can be written as x minus 1 into x plus 1. X plus 1 factor will get cancel. Now we take d by dx of x minus 1 upon x plus 1 by using the quotient rule, derivative of division of two functions. So we get denominator square. Denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. We get x plus 1 into 1 minus x minus 1 into 1 divided by x plus 1 bracket square. We get x plus 1 minus x plus 1 divided by x plus 1 bracket square. X will get cancel. Here sign will be changed in subtraction. So we get 2 upon x plus 1 bracket square. Therefore I can be written as integral of e to the power x into x minus 1 upon x plus 1 plus d by dx of 2 upon x plus y 1 bracket square is the derivative of this function, x minus 1 upon x plus 1 into dx, and integration of this function is e to the power x into x minus 1 upon x plus 1 plus c. So this is the required solution of this example. Now we are going to take next type of example. दिसेना का integral of e to the power x into 1 minus x upon 1 plus x square bracket square dx. I want to find the integration of this function. Now this can be written as, by using the law of indices, a upon b to the power m can be written as a to the power m upon b to the power m. E to the power x into 1 minus x bracket square can be written as 1 minus 2x plus x square divided by 1 plus x square bracket square dx. Now we separate the divide, we get integral of e to the power x into 1 plus x square upon 1 plus x square bracket square minus 2x upon 1 plus x square bracket square dx. Now this can be written as integral of e raised to x into 1 upon 1 plus x square minus 2x upon 1 plus x square bracket square dx. Now we take the derivative of 1 upon 1 plus x square d by dx of 1 plus x square raised to minus 1. We get minus 1 into 1 plus x square raised to minus 2 into 0 plus 2x. We get minus 2x upon 1 plus x square bracket square. This is the derivative of 1 upon 1 plus x square. We get, I can be written as integral of e to the power x into 1 upon 1 plus x square plus d by dx of 1 upon 1 plus x square with respect to x, and integration of this function is e raised to x into 1 upon 1 plus x square plus c. So this is the solution of this example. Now we are going to take the next type of example. Now we are going to take the example on same method by using, we have to solve this example by using the substitution method. Integral of sin of log x plus cos of log x dx. I want to solve this example by using the substitution method. Let I is equal to given function. Now we put t is equal to log x. Therefore x is equal to e raised to t. By using the definition of logarithm, here base is nothing means e, so we write in the exponential form. Now take the derivative, dx is equal to e raised to t dt. Differentiate x with respect to t, we get this function. I can be written as e raised to t into sin t plus cos t dt. Derivative of sin t is cos t and derivative of cos t is minus sin t, means derivative of cos t does not adjust here. Here derivative of sin t is the cos t. E raised to t into sin t plus d by dt of sin t dt. We get e raised to t into sin t plus c. And what is the value of e raised to t? X into sine of log x plus c. So this is the integration of this function. Now we are going to take the same type of example, means substitute t is equal to log x. Integral of 1 upon log x minus 1 upon log x bracket square dx. Second example. In this example, we also substitute t is equal to log x. So x is equal to e raised to t. Therefore, dx is equal to e raised to t into dt. Let I is equal to this function. I can be written as integral of 1 upon t minus 1 upon t square into e raised to t dt. Now this can be written as integral of e raised to t into 1 by t plus d by dt of 1 by t dt. Derivative of 1 by t is minus 1 by t square. We get e raised to t upon t plus c. And what is the value of e raised to t? X upon t log x plus c. This is the integration of this function. Now we are going to take next type of example. So the substitution is the same for the next type of example. Integral of log x upon 1 plus log x bracket square dx. In this example, we also substitute t is equal to log x. Then x is equal to e raised to t. Therefore, dx is equal to e raised to t into dt. So I can be written as t upon 1 plus t bracket square into e raised to t dt. Now here denominator function contain 1 plus t, add 1 and subtract 1, e raised to t into 1 plus t minus t divide by minus 1 divide by 1 plus t bracket square into dt. Now separate the divide. So we get I is equal to integral of e raised to t into 1 upon 1 plus t minus 1 upon 1 plus t bracket square dt. And now d by dt of 1 upon 1 plus t is equal to d by dt of 1 plus t raised to minus 1. Minus 1 into 1 plus t raised to minus 2 into 0 plus 1. So we get minus 1 upon 1 plus t bracket square. So we get, so this function can be written as minus 1 upon 1 plus t bracket square. Now this can be written as e raised to t into integral of e raised to t into 1 upon 1 plus t minus d by dt of 1 upon 1 plus t dt. So this can be written as e raised to t into 1 upon 1 plus t plus c, and value of e to the power t is x upon 1 plus log x plus c. This is the required answer. Now we are going to take next type of example. Integral of e to the power sine inverse of x into x plus under root 1 minus x square divided by root 1 minus x square dx. Let I is equal to this function. Now this can be written as integral of e raised to sine inverse of x into x plus under root 1 minus x square into 1 upon root 1 minus x square into dx. Now here we substitute, put t is equal to sine inverse of x. Now differentiate this t with respect to x. We get dt is equal to 1 upon root 1 minus x square into dx. Then we substitute x, and x is equal to sine t. T is equal to sine inverse x, then x is equal to sine t. I can be written as e raised to t into sine t plus under root 1 minus sine square t into dt. We get e raised to t into sine t plus cos t dt, and this can be written as integral of e raised to t into derivative of sine t is cos t d by dt of sine t into dt, and integration of this function is e raised to t into sine t plus c. And what is the value of sine t? X. X into e to the power sine inverse of x plus c. So this is the integration of this function. This is the last example on this method. There are three formulae, standard formulae. We will see the result of these three formulas only. Integral of the form of the form root a square minus x square root a square plus x square root x square minus a square. Now we want to take the results only, not necessary to take the examples on it. First, integral of 1 upon integral of root a square minus x square dx is equal to, we prove this, all these example by using the integration by parts. So here x by 2 into under root as it is function a square minus x square plus a square by 2 into sine inverse of x by a plus c. Second one, integral of under root x square plus a square dx. This can be, result of this example is x upon 2 into under root x square plus a square plus a square by 2 into log of x plus under root x square plus a square plus c. And third one, integral of root x square minus a square dx is equal to x by 2 into under root x square minus a square minus a square by 2 into log of x plus under root x square minus a square plus c. So these are the important result which are depend on integration by parts. In this function, first function root a square minus x square and second function take as 1 and apply the integration by parts and we get all these three results. So today we will stop here.